Hello, good morning, everybody. Today we will start the heart, which is a part of your cardiovascular system. You know that heart, blood vessels, and blood belong to the cardiovascular system. Cardio means heart, and vascular indicates the blood vessels. What are the blood vessels? Blood vessels are arteries, veins, and capillaries. So those are three types of blood vessels in cardiovascular system. So heart is the main organ which pumps the blood. And first today we'll talk about the heart. We'll see the location of the heart in your body. Then we'll talk about the circulation of blood. There are two types of circulation, systemic and pulmonary. There are two other types of circulation. One is called portal, another is called fetal circulation. We'll talk about that. Then we'll talk about the coverings of the heart to protect the heart, surface of the heart. If you look the heart from outside, what are the structures you will be able to see on the surface. Then we'll talk about the wall of the heart, anatomy of heart muscle, which is actually how the heart muscle tissue looks under the microscope. You have already seen that in NP1. Then we'll talk about the coronary circulation and heart valves. First, the location. Heart, a conical shaped organ. The shape is conical, cone shaped. That means it has a pointed end, right? Located in the thoracic cavity. This is your thoracic cavity, located inside the thoracic cavity, and mostly in the left side of the thoracic cavity. Why I said mostly in the left side? Because 2/3 part of your heart is in the left side, only 1/3 is in the right side. So it is like this. Look at me. Most part is in the left side, then 1/3 part goes to the right side. Okay, so mostly in the left side. There is a cavity inside the thorax. That cavity is called mediastinum. So you know that you have inside the pleural cavity, and in between this space between two lungs is called mediastinum. Between two lungs or two pleural cavities, and your heart is located here. Okay, so this is your heart, and this pointed lower left end is called the apex. So apex is the lower pointed end directed down and to the left. This is left side, so downwards and to the left. Now if you see the picture, you can see here between two pleural cavities or between two lungs you have the heart, and lower left end is called the apex. Okay. Another thing you need to know, if I ask you to locate the heart from outside, there is a way. this is your first rib, right? Second rib, and the space between the ribs is called intercostal space. So your heart is located between the second, this is first intercostal space, this is second intercostal space. So your heart is located between second and fifth. So this is third, fourth, fifth here. So this is the location. Upper end is here, second intercostal, and lower end is in fifth intercostal space. And the size of your heart is like the size of your fist. So this is the size of the heart. Circulation. So that's the location of your heart. Now, blood circulation in your body. First we divide the circulation into two types. Adult circulation and fetal circulation. Adult circulation are three types: systemic, that's the largest one throughout the body; pulmonary; and portal, also called hepatic portal circulation. So those three types of circulations are present in the adult body, adult person's body: systemic, pulmonary, and portal or hepatic portal. Now just know that systemic circulation is the circulation between the heart and the whole body. Between the heart and the whole body is the systemic circulation. Pulmonary circulation is between the heart and the lungs. You know, pulmonary means lungs, you all know that. So between the heart and two lungs, that's the pulmonary circulation. Portal circulation is the circulation, it is not directly attached to the heart, between your GI tract and the liver. Good. What happens? The nutrients are absorbed, right? In the intestine, right? And that nutrients are taken from the intestine to the liver. So that is the circulation called portal circulation or hepatic portal. Hepatic means liver, hepatic portal or GI tract and the liver. So between GI tract and liver. So those are three types of circulation present in the adult human body. Fetal circulation is the circulation between the mother and the fetus inside the uterus. You know, fetus is in the uterus. So that is the fetal circulation. Mother's blood goes to fetus to provide nutrition, oxygen. That is the fetal circulation. Okay. Now, this picture is showing the systemic and pulmonary. Those two types of circulation, those are directly related, attached to the heart. So, let's first talk about the pulmonary circulation. Pulmonary circulation is the circulation between the heart and what? Two lungs, right? Pulmonary. Now you tell me, simple question. Why blood goes to your lungs? To get the oxygen. We all know that, right? Blood goes to the lungs to get what? Oxygen. So what type of blood goes to the lungs? Oxygenated or deoxygenated? Deoxygenated, right? So heart sends the blood to the lungs. What type of blood? Deoxygenated blood. Is it clear? And inside the lung, what happens? Blood gets oxygen, becomes oxygenated. Is it clear? And oxygenated blood comes back into your heart. Is it clear? So that is the pulmonary circulation. From the heart, deoxygenated blood goes to the lungs, where blood gets oxygen, right? And oxygenated blood comes back into your heart. That is what? Pulmonary circulation. Is it clear? So in this picture, you see from the heart, blood goes to your two lungs. The blood goes to the lungs, showing here by blue color. That means deoxygenated blood, right? Then inside the lung, you see the lower part of the lung, blood becomes oxygenated. That means red, and then comes back into the heart. Now, systemic circulation. After your heart receives oxygenated blood from the lungs, oxygenated blood is sent to the body, because body needs oxygen, right? All tissue of your body, whole body needs oxygen. You know that, right? So that oxygenated blood from the heart goes to the body. Blood goes to the body to give oxygen to the body, right? To the tissue. And receives carbon dioxide, because your tissue is continuously producing carbon dioxide, right? It needs oxygen for metabolism, and carbon dioxide is being produced by metabolism. So blood is giving oxygen to the body and getting carbon dioxide from the body. So again, so heart sends what kind of blood to the body? Oxygenated or deoxygenated? Oxygenated, clear? Because body needs oxygen. And gets carbon dioxide from the body. So blood becomes oxygenated, blood becomes deoxygenated, right? Because it is getting carbon dioxide. And that deoxygenated blood comes back into your heart. Is it clear? So that is the systemic circulation between the heart and the body. So if you know the purpose, why blood is going to the lungs? To get the oxygen. Why is blood going to the body? To give the oxygen, right? So that's the purpose. Now, if I ask you to tell me few differences between the pulmonary and systemic circulation. Pulmonary circulation, systemic circulation. Pulmonary is between the heart and the what? Lungs, right? Systemic is between the heart and the body. Now you tell me, which is long circuit circulation, systemic or pulmonary? Pulmonary is between, see, look at me, between the heart and two lungs, right? Lungs are very close to the heart, right? So this is a short circuit circulation. So pulmonary is a short circuit circulation. Systemic is between the heart and the whole body. So it is a long circuit circulation. Okay. Now you tell me, simple question. To send the blood from the heart to the lungs, you need more pressure, or from the heart to the whole body? Whole body, right? Very simple, because to send something near, you don't need to push strongly, right? But if you want to send far, you need to push or pump strongly. So pulmonary circulation is a low pressure system. Systemic circulation is a high pressure system. Okay? High pressure system. Then you can say that in case of pulmonary circulation, deoxygenated blood is carried by artery. So arteries carry deoxygenated blood and arteries. In pulmonary circulation, arteries carry deoxygenated blood because you know that from the heart, deoxygenated blood goes to the lung, right? And now one thing you need to know that any blood vessel that takes the blood away from the heart, out from the heart, that is artery. We don't care what kind of blood. Is it clear? So the blood vessel that takes out blood from the heart, that is what? Artery. So from the heart, deoxygenated blood is taken to the lung, right? So those arteries are arteries taking the blood, carry deoxygenated blood in pulmonary circulation. In systemic circulation, arteries carry oxygenated and veins carry carbon dioxide rich blood. So opposite, just opposite. In case of pulmonary, arteries carry deoxygenated, vein carry oxygenated. In case of systemic, arteries carry oxygenated, veins carry deoxygenated blood. Okay, so those are few differences between the pulmonary and systemic circulation. Okay. Now, little more detail. Two things are very important to remember to understand systemic and pulmonary circulation. Number one, you need to know, always keep in mind, this will make it very simple. Right side of your heart is with deoxygenated blood. Okay, so right side of your heart is for deoxygenated blood, and left side is for oxygenated blood. So very simple. If this is your heart, you have how many chambers? 4, right? So this is right atrium, right ventricle, left atrium, left ventricle. You already know that. So this is the heart. So you see, this side oxygenated, this side deoxygenated. So you have oxygen rich blood in this side, left side, and carbon dioxide rich blood in the right side. Okay, you can write down O2, CO2. Okay, that is one thing you need to remember. Number 2 is atria. Atria means 2 atrium, plural. Atria receives blood from outside and gives to the ventricle. So that is the receives blood from outside, and gives to the ventricle. And first thing, ventricles pump the blood or send the blood to the outside. Send blood to outside of the heart. Okay. So if you just remember these couple of things, number one, right side of the heart is for what? Say loud. Deoxygenated blood. Left side is for oxygenated blood. Is it clear? That is one thing you have to remember. Number two, atria does what? Receive the blood from outside, right? And give to the ventricle, same size ventricle. Is it clear? And ventricle pumps the blood to the outside, send the blood to the outside. Is it clear? If you just remember those two things, you'll see everything will get clear. Okay? Now, you already know that blood goes to the lungs to get what? Oxygen, right? So what kind of blood goes to the lungs? Deoxygenated. Is it clear? Okay. So now you tell me from which side blood should go to the lungs? Deoxygenated blood. From left side or right side? Right side, because right side has deoxygenated blood, right? And I already mentioned here, who pumps the blood to the outside? Atrium or ventricle? Ventricle, right? So now you already know that deoxygenated blood goes out from the right ventricle. Is it clear? Where? To the lungs. Make sense? So from right ventricle, we know that only ventricle pumps the blood to the outside. Atria receive. So right ventricle sends deoxygenated blood to the lungs. Is it clear? Okay. And then inside the lung, what happens? Blood gets oxygen, right? And becomes oxygenated. So now oxygenated blood, heart. Which chamber receives the blood from outside? Atrium. Is it clear? So that oxygenated blood, and which side it should come, because it is oxygenated now? Left side, right? Is it clear? Okay, so now we know that blood must come here to the left atrium, because atrium receives blood from outside. Okay, so that is the pulmonary circulation. Right ventricle sends deoxygenated blood to the lungs, blood gets oxygen and comes back to the left atrium, oxygenated blood. Is it clear? So between the heart and the lung, that is what? Pulmonary circulation. Make sense? Okay. So in pulmonary circulation, arteries and veins are called pulmonary arteries, pulmonary veins. So very simple. Pulmonary arteries and pulmonary veins. So you see, that is the pulmonary circulation. Now you understand. Artery always takes the blood vessel that is taking the blood outside, that is artery. So this is artery and carrying oxygen rich blood. This is vein, this is vein bring the blood to the heart, that is vein, oxygenated blood. Now let's see the systemic circulation. Now we know that in systemic circulation, what kind of blood goes to the body, oxygenated or D? To the body, oxygenated, right? Body needs oxygen. So from which side blood will go to the body? Left side. Is it clear? And who pumps the blood to the outside? Ventricle. So left ventricle sends blood to the body. Make sense? What kind of blood? Oxygenated blood. And then blood gets carbon dioxide. So carbon dioxide rich blood should go to which side? Right side. Because this is carbon dioxide rich compartment side. And who receives blood from outside? Atrium. So right atrium receives carbon dioxide rich blood from the body and then gives to the same size ventricle, right? Now again you see right ventricle got deoxygenated blood, carbon dioxide rich blood, it will send to the lungs again, come back up into the heart. So that is the systemic circulation. Make sense? So if you just know the purpose, why blood is going to the lungs? To get the oxygen, right? Why blood is going to the body? To give the oxygen. Is it clear? And which side of the heart deals with oxygenated blood? Left side. Which side deoxygenated? Right side. Who receives the blood from outside? Which chambers? Atrium, right? And gives to the same size ventricle. Is it clear? And ventricles only to what? Pumps the blood to the outside. Sends the blood to the outside. So if you just keep remember those few things, you can explain if I ask any question. Structure of the heart. Covering of the heart is called pericardium. Peri means around, cardium is heart. So around the heart, the covering, connective tissue covering, that is called the pericardium. That is a protection. If you see the wall of the heart wall is mainly formed by the cardiac muscle, special type of muscle, highly specialized type muscle that can contract and relax involuntarily throughout the life. You know that. Now inside the heart you have, those are the upper chambers and two chambers. Valves. There are 4 sets of valves. How many? 4 inside the heart. 2 sets are called AV valve. Right and left AV valve. Right AV valve is called tricuspid. Okay, and left AV valve is also called mitral or bicuspid. The reason is, in right side you have 3 cusps. Cusp means leaf-like. The word cusp, 3. So in right side you have 3 cusps. In left side you have 2 cusps. That's why called tricuspid and bicuspid. So those 2 AV valves and 2 sets of semilunar, half moon, partial moon, semilunar are aortic at the root of aorta. Aorta is the blood vessel that takes oxygenated blood out from the heart to the body. So this is aorta. Large artery that takes oxygen rich blood out from the heart to the body. So at the root of aorta you have one semilunar valve, that is the aortic semilunar. At the root of pulmonary trunk you have another set. And AV valves are between atrium and ventricle. You already know that. AV, atrioventricular, between the atrium and the ventricle. So when AV valves open, they let the blood move from atrium to the ventricle, same sides. Okay, this way. And when the semilunar valves open, they let the blood enter into the pulmonary trunk and aorta. Okay, so those are four sets of valves. Now, so at the root of aorta, you have one semilunar valve, that is the aortic semilunar. At the root of pulmonary trunk, you have another set. And AV valves are between atrium and ventricle. You already know that. AV, atrioventricular, between the atrium and the ventricle. So when AV valves open, they let the blood move from atrium to the ventricle, same sides. Okay, this way. And when the semilunar valves open, they let the blood enter into the pulmonary trunk and aorta. Okay, so those are four sets of valves. Now, blood vessels in the heart. In the heart, there are two types of blood vessels. In the heart, there are two types of blood vessels. What are those two types of blood vessels? One type of blood vessels are these. You see here, I have shown you. Take the blood out or bring the blood in. So, that is one type of blood vessels. These are large, very big blood vessels. Taking the blood either out or bringing the blood in. So, those are large blood vessels. To take the blood out from the heart or bring the blood in. And small blood vessels, another type of blood vessels, those are to supply blood to the wall of the heart, and that is called the coronary circulation. So small blood vessels, those are to supply blood to the wall of the heart, cardiac muscle. Those are coronary arteries or coronary blood vessels, called coronary circulation. So the purpose of large arteries is taking the blood out or bringing the blood in. That is the purpose of large blood vessels. That is one type of blood vessels attached to the heart. Another type, small blood vessels, those are going to the wall of the heart and supplies oxygen to the cardiac muscle. That is the coronary circulation. Okay. Special nodes and conductive tissue. In the heart, you have nodes. Nodes are tiny round structures, and those nodes do what? Produce the electrical impulse, electrical signal, like battery. Repeatedly producing electrical impulse. Have you heard SA node? Pacemaker, right? SA node is called pacemaker, probably all of you have heard. So that is one node, SA node, that is producing electrical impulse one after another throughout the life. There is another node called AV node. So just know that those are the nodes inside the heart, right? The function is what? Producing electrical signal or impulse, right? And that signal must be transmitted throughout the heart. That is the conductive system. So nodes are producing electrical impulse, but that electrical impulse must go to the heart everywhere, and that is the conductive system that transmits that impulse throughout the heart. So just know that there are nodes and conductive tissue. Nodes are to produce impulse and conductive tissue to transmit. If the impulse is produced only in one tiny node, does not spread to the heart, right? Then heart will not get the signal. So you have conductive tissue there. We'll talk about that later. Just know that you have nodes and conductive tissue to produce and transmit what? Electrical impulse. Very important. If the nodes doesn't work, your heart will not contract. Coverings of the heart. Your heart will not contract. Coverings of the heart is the pericardium. Peri is around, I have mentioned already. So around the heart, you have connective tissue covering. That is the pericardium. Now, that pericardium has two layers. So it is a double layered serous membrane. So let me write it down. Double layered serous membrane. It is a connective tissue structure. So now, why is it is a double layered serous membrane? If you see the pericardium, one layer, which is the inner layer, is attached to the surface of the heart like this, and then it turns like this, and then goes like that. So this is one layer attached to the wall, and then another layer goes like that and like this. Okay, so balloon. If this is your heart and this is a balloon. If you push your fist on the balloon, what will happen? It will cover your fist, right? Your fist will go in, right? Now that balloon has how many layers? One is attached to the hand, right? And there is a gap here, and then another, right? So exactly same, like if you put your fist, you have two layers around. One is attached to the heart, and then another is the outer one, and there is a space between. There is a space. So the inner layer is called visceral layer, or visceral, yeah, you can say visceral layer, and the outer one is called parietal layer of pericardium. Okay, and the gap between these two is called pericardial cavity or space. Pericardial cavity. Okay, so that is the pericardium. Now in this space you have the fluid. That is very important. That fluid is called pericardial fluid, right? Pericardial fluid in that space. Fluid. Now, that fluid is a lubricating type fluid. That fluid is what kind of fluid? Lubricating, slippery. Okay. So when your heart is doing what? Expanding and contracting, right? Now, when your heart expands and contracts, these two layers move like this in opposite direction. Okay? So, that fluid in between is preventing friction between those two layers. Make sense? Because when your heart contracts and expands, the layers move in opposite direction like this. So, the presence of that fluid is very important, right? Because it is a slippery, lubricating type fluid. So, that prevents the friction. Otherwise, when if friction occurs without that fluid, that will create sharp pain, severe pain in the heart, and that happens. Have you heard the clinical condition pericarditis? So pericarditis, itis is inflammation. If inflammation occurs in the layers, then what happens? The fluid amount decreases. Okay, so friction occurs, and that causes severe pain, sharp pain. So pericarditis, itis is the inflammation of pericardium. If too much fluid accumulates here, this space gets filled with too much fluid, that causes a problem too. In that case, the pressure around the heart increases. Make sense? If too much fluid accumulates there, the pressure around the heart increases. So heart cannot expand. Make sense? If pressure is more around the heart, heart will not be able to expand. So that is a clinical condition too, and that is called tamponade. T-A-M-P-O-N-A-D-E. Tamponade. Okay. Accumulation of fluid or pressure, increased pressure around the heart decreases the expansibility of the heart. Okay. External of the heart. If you see a heart from outside, what are the things you will be able to see? You did the dissection of the heart, right? Already? So you have seen the heart from outside. Can you detect the atrium and ventricle? Can you separate the left and right ventricle from outside? You did it, right? Remember? By looking at the what? Interventricular sulcus, right? That line. And that is one way. Another is what? Look at me. Another is what? You can see the thickness, right, of the wall by pressing which wall is thick, right? So there are grooves or sulcus, right, lies. By looking at those, you can tell this is interventricular sulcus, so this is left ventricle, this is right ventricle, right? Another is you can press with your finger and tell which wall is thick, right? So that is another one. So yes, you can identify the atria and ventricles from outside. You can tell these are atria, these are auricles, these are ventricles. How? The wall of atria is thinner than the wall of ventricles. Now, you can also separate right and left ventricle because left ventricular wall is few times thicker than the left ventricular wall. You can also see the sulci. Some people say sulci. or sulci. I say sulci. So by looking at those grooves, shallow grooves, you can also identify the chambers. What are the sulci? Sulci is plural, sulcus is singular. So if I indicate only one, that is sulcus, more than one, sulci. Okay. So you have anterior interventricular sulcus that you have already seen. You have posterior interventricular sulcus in the back. That one you also have seen already in the real heart. And those grooves or sulci contain blood vessels and fat. So blood vessels, arteries, veins and fats are located in the sulci. Now let's see the external of your heart. If you see this picture, this is the front of the heart. So you can see the anterior interventricular sulcus. Right? Anterior interventricular sulcus. Now you see it contains the blood vessels, that means arteries and veins, and fat. There is another sulcus which is very important, that separates atria and ventricles. That is called the coronary sulcus. This one. This one. So above that atrium, below ventricle. So between atria and ventricles is the coronary sulcus. So you see from outside you can actually tell where the atria and ventricles, which one is right ventricle, which one is left ventricle, by looking at those sulci. Okay, now we have already talked about four chambers, right? And their functions, you already know that, I explained that. We have already talked about the valves. How many sets of valves you have? Anybody remember? Four, right? Two sets of AV valve and two sets of semilunar valves, right? So you already know, just know that valves are doing what inside the heart? Valves regulate two things, the direction of blood flow and the amount of blood flow. So direction and the amount I have already explained. So this is your right AV valve here, only opens downwards, it won't open upwards. So it only allows the blood to enter into the ventricle from the same size atrium. So AV valves only opens which way? Which way? Down, right? So opens like this, so blood will rush into the ventricle. Now you see, when your ventricle contracts, ventricle sends blood where? To the outside, right? To the outside. So when ventricle contracts, for example, this is left ventricle. When left ventricle contracts very forcefully, should the blood go to the atrium or outside? Outside, right? Should it go to the atrium? No. That is meaningless, right? If it goes back to the atrium. So when the ventricle contracts, this valve, AV valve, will close this. Make sense? So blood will not be able to go back to the atrium. Only way is going outside. Make sense? So when ventricle contracts, semilunar valves open here upwards to let the blood get out. Semilunar valves open this way, okay? So the blood will get out. Very simple. To send the blood out, valves must open, should open this way, right? AV valve coming from atrium to ventricle. So we'll open this. Okay. So unidirectional gates, and now you know why. So valves regulate the direction of blood flow. Is it to get out or move? That is very simple, right? So how much opening is there, that determines the amount. So amount and direction, those two things are controlled by your valves. Sometimes you know that valves get hard. Normally the valves are very soft and flexible, can easily move. But if that ability is lost, that is called stenosis. It's a valvular stenosis. Okay. Hardening of the valve. So lazy valve. We have already talked about 4 sets of valves, and I have explained you how they work. So here you can see those 4 sets of valves. This is the real transverse section. So you can see those 4 valves. Inside the ventricle, you have the papillary muscles. You have seen when you did the dissection. And from the papillary muscle, you have also seen that string-like structures arise. Those are called chordae tendineae. And the other end of these strings or chordae tendineae get attached to the valves, right? AV valves. So the movement of the valve is controlled by these strings, chordae tendineae. Wall of the heart. If you see the wall of the heart, this wall has 3 layers. From outside to inside, outermost very thin layer is called epicardium, which is nothing but the visceral. Now you look at this picture. You remember I said that one layer of pericardium is attached to the surface of the heart. That's the inner layer, visceral layer. So if now I see the wall of the heart, the outermost layer is a thin layer, which is actually visceral pericardium, right? The first layer I'll get is visceral pericardium. So that is called epicardium. You see that epicardium is a visceral pericardium. Then you have the middle thick layer, which is very thick, and that is cardiac muscle. Cardiac muscle tissue. That is called myocardium. Myo means muscle, remember. So, middle thick layer of cardiac muscle, which is called the myocardium, and this one is responsible for the contraction and relaxation, because muscle, highly specialized muscle. And then innermost very thin layer, that is an epithelial lining. You know, epithelium is a thin structure. So that is the innermost to make the surface smooth. So that is the endocardium. Endo means inside. So epicardium is visceral pericardium, myocardium is cardiac muscle, and innermost thin layer is the endocardium, which is epithelial lining. Okay, so under the microscope, how it looks like. You have already seen it in NP1. Plenty of large mitochondria present inside the heart muscle fiber. Why? What do you think? Mitochondria are called what? Powerhouse, right? They produce ATP, right? Most of the ATPs are produced in mitochondria. That's why in NP1 we talk about it. So mitochondria are powerhouses. They produce ATP. Why? Heart muscle has plenty of mitochondria. Now you know, right? Because heart muscle is doing what? Restless. Even when you are sleeping, other muscles are relaxed. Heart is not taking any rest, right? So continuously contracting. Is it clear? So it needs to produce ATP continuously. Here, how the heart muscle looks like under the microscope. This is a very familiar picture, should be to you. You have seen this in picture under microscope. The heart muscle fibers have thin striations. You can see under the microscope the heart muscle fibers, cylindrical fibers, number one. So number one, cylindrical fibers. Number two, inside the fiber you have thin lines. Those are called striations. And cylindrical fiber. Like this, striations, and between two fibers you have intercalated discs. So this is another fiber. This is intercalated disc. Okay, another intercalated disc. This is another fiber, striations. And another thing is, often we see branching between the fibers. So this is a branch going from one fiber to another. Okay. So, and usually single nucleus. Occasionally we see two, but usually single. So that is the property of cardiac muscle. What kind of property? Histological. That means under the microscope. Without microscope you won't see this. Okay. Now this intercalated disc is a very important structure in the heart muscle. Why? Because two types of intercellular junctions are present here. You must remember in NP1 we talked about three types of intercellular junctions. Tight junctions, remember that? Gap junctions and desmosomes. Did you hear those? Anybody? Some memory? Tight junctions, gap junctions, and what? In intercalated disc, you have desmosomes and, look at me, hold the fibers or cells like this, like zipper in your cloth, very strongly like this. Okay, so the protein structures, linker proteins, come out from the cell members like this, and here hold the cells very strongly like this. That's the desmosome. Okay, so the fibers are strongly attached to each other. Is it clear? Number one. Number two, at the same time you have channels, gap junctions in the intercalated disc. So both desmosomes and gap junctions or channels are present. So what happens? You see, the fluid or ions can quickly move from one fiber to the next because of the channels. The ions, sodium, potassium, calcium, right? Those are used for contraction and relaxation. So those ions can quickly get changed between the fibers, and that is very important. And desmosomes are holding the fibers together. So now you see both junctions, gap junctions and desmosomes are very important for the heart muscle fibers to work together. Work together. Why? If I keep the doors open between the rooms, right? So you can easily talk to each other. if I close the door, you are isolated. Make sense? So those channels are open, ions can be quickly exchanged, right? So they can communicate quickly. Is it clear? That is one. So they can all work together. Number two, since they are held very strongly by desmosomes like this, no one can stay lazy. Have to work, right? If one contracts, it will pull another one, right? So all heart muscle fibers are strongly connected by those two junctions. One is chemically connected, right, by the channels. Another is physically connected by the desmosomes. Make sense? Those two things make the heart muscle fibers all work together quickly at the same time. And that function has a name that is called syncytium. That function of working together is called syncytium. Working together. Like a single. Many muscle fibers are working together like an unit. Single. That is very important because heart muscle must contract quickly. Okay. So here you see inside the fiber many mitochondria. We already know that it's the many mitochondria. Coronary circulation. You remember I told you there are two types of blood vessels. Large blood vessels are to take the blood out and bring the blood in. So those are the large blood vessels. Small blood vessels in the wall of the heart called coronary circulation. So small blood vessels in the wall of the heart. Heart's own circulation. We know that heart gives blood to the body, but heart needs its own circulation for its own tissue. That is the coronary circulation. Is it clear? To keep the heart alive. Heart can work for others, but if it doesn't, get blood cells in its own tissue, it won't be able to work, right? So that is the coronary circulation, heart's own circulation to keep the heart tissue alive. Those are small blood vessels, definitely. So in coronary circulation, you have coronary arteries and veins. You need to know the name of those arteries and veins. Okay. Arteries include right and left coronary arteries. Those are the largest. Right and left coronary arteries. Then in the wall you also have marginal artery, circumflex artery and interventricular arteries. Veins in the wall of the heart, you have great cardiac vein, small cardiac vein, anterior cardiac vein. Also add another one that is also important and large, middle cardiac vein. So the names are easy. Great, middle, small and anterior cardiac vein. There is a short, wide vein in the back, is not listed here. I showed you that one in the model. That is called coronary sinus. So add this one too. Coronary sinus is a short but wide vein in the back of the heart. So most of these veins, you see, small cardiac vein, anterior, great cardiac vein, middle cardiac vein, these veins give blood to the coronary sinus. and then from coronary sinus blood is given to the right atrium of the heart. Deoxygenated blood, goes to the right atrium. So coronary sinus receives blood from these veins, most of these veins. So now coronary circulation has two important properties. One is called anastomosis and another is collateral. Very simple. If you see the coronary arteries, like this is one coronary artery, this is another coronary artery, another artery. The arteries in the coronary circulation give many lateral branches. These are called collaterals. That is one property. Okay, many collateral branches or many collaterals. Number two, anastomosis. These collaterals give branches like this and they get connected to each other like this. So all collaterals give branches and the branches get connected to each other, and that is called anastomosis. Is singular. If I only indicate one, that is anastomosis. If I indicate more than one, anastomosis, S-E-S. Okay, so collaterals and anastomosis are plenty in the coronary circulation. Now, why these two things are important in terms of supplying blood to the heart? Heart is very important, right? We must keep the heart alive. So, you see what happens because of collaterals and anastomosis. If any blockage occurs anywhere, okay, like if any blockage occurs here, through these collaterals, blood will go to go like this, come back like this. Make sense? So, alternate route will be open. So, this area will still get some amount of blood. So, blood will go this way, come here. Although it is blocked here, but this tissue will get blood. Sometimes, if large coronary arteries get blocked, that is a problematic. So, in that case, if blockage occurs here, this area, if for example partial blockage occurs, some blood will come here. But this tissue will suffer from lack of oxygen. Makes sense, right? Less blood is going there. So that will cause pain in that area of the heart. And that is called what? Anybody? Angina? Yeah. Angina pectoris. Angina means pain. The word angina means what? Pain. Pectoris means what? Pectoral. Pectoral. Pectoral is measure. Why? Where? Chest, right? So pectoralis, you need to link. Pectoralis means chest. So pain in the chest. But occasionally we see the pain, this pain although originate in the heart muscle, this pain spreads. For example, the pain from here can go to the arm, shoulder, right? Or even all the way to the fingers. So that is called a referred pain. It is felt far away from the origin. Make sense? So, although the origin is in the heart. So anyway, that is angina pectoris due to partial blockage of the artery. Now, how you can treat that patient? You know, those patients keep the medicine all the time, nitroglyceride, put usually under the tongue, right? So that medicine does what? Expands the blood vessel, dilate the blood vessel, right? So now if I can dilate this blood vessel, more blood will go there. Is it clear? Although the blood vessel is narrow, now I have used the medicine to expand it, right? So more blood will go there, that will reduce the pain. Now, yes?
So the cells are still alive?
In this case, suffering from in infarction, the cells die.
They all die.
Yeah, cells die. But in myocardial, in angina pectoris, the cells are suffering from lack of oxygen. But you are right, if complete blockage occurs and this tissue doesn't get enough oxygen and die, in that case, if tissue death occurs, in that case we say myocardial infarction, which is actually heart attack. Myocardial infarction or heart attack. In common term, it will use this. Okay, that is the death of the myocardium. Now, if you see this picture, you can see the important arteries in coronary system or coronary circulation. You see the left coronary artery, you see the right coronary artery, you see the marginal artery, you see the circumflex. The word circumflex means circling around. So circumflex artery goes like this. Okay, so this is circumflex artery. If I point here, this is circumflex. If I point here, that is also circumflex, right? So you need to know that circumflex means circling around. So anywhere if I point, that is circumflex. Anterior, posterior, interventricular arteries, very simple, present in the interventricular sulcus. Those grooves in between the ventricles, right? So here, this is front view, so you can see anterior interventricular artery, right? You can also see anastomosis, right, and collaterals here. You can see the veins. You remember the short, wide vein is called the coronary sinus that I just wrote. It receives blood, deoxygenated blood from most of the veins and gives to the right atrium. So this is coronary sinus. Now you can see short, wide part, only that part. You can see anterior cardiac vein, great cardiac vein. There are middle cardiac veins and a small cardiac vein, right? So those are the veins, the coronary circulation. You need to just remember the names and two important properties. These two are very important. Okay, I'll ask in your test. So collaterals and anastomosis. So let's stop here. Okay. And gives to the right atrium. So this is coronary sinus. Now you can see short, wide part, only that part. You can see anterior cardiac vein, great cardiac vein. There are middle cardiac veins and a small cardiac vein, right? So those are the veins, the coronary circulation. You need to just remember the names and two important properties. These two are very important. Okay, I'll ask in your test. So collaterals and anastomosis. So let's stop here. Okay.